Okay, welcome everyone. So we are here with VMware. Shivi will be giving the presentation. We're happy to have you all here. And I guess, yeah, I'll just hand it off to Shivi.
All right. Thank you everyone for making it. This is probably not the
Before you keep going, we see the slide deck. We don't just see the one slide, we see kind of all of them.
okay. All right. Thank you for pointing that out. How about now?
Yeah, that's good.
All right. Sorry about that. So thank you for coming. Thank you for dealing with the pandemic as it is, unprecedented times, and taking the time to listen in, join a group. I'm excited to be here today. This is the first time I'm presenting at NUWIT, and I have been in a few other women-only conferences, and this is by far the most, I would say, intimate that it has gotten. It's a smaller group, and we're able to chat with one another. So I intend for this discussion to stay that way, for us to have kind of an open conversation going on. I would encourage you to ask questions if you pause and kind of double click on a few points. We can do that as well. Yeah, let's get started. So what I was hoping to cover today is Cloud Director Service, which is the team that I'm on, and the technology trends of today and how we actually put them to use in our project. We're all following the developments in technology. We hear a whole bunch of technology buzzwords, but sometimes it becomes difficult to put a picture together to see how these different pieces of the puzzle fit. Sometimes we only end up using some parts of the solutions. In other cases, the implementation, the application of such technology is more elaborate, complex, but I was hoping to kind of tie all of this together to show you how we could run a service in production globally at an enterprise scale, and if effectively use all of these technology trends. Um, Moving on to the next slide, just to give everyone an introduction about me. I'm Shivi Murugesan. Who I am is primarily, I am the mom of two really busy bodies. That's my full-time job. And I am an avid VMware Kool-Aid drinker. I've been at VMware for over 11 years. A good amount of my career has been at VMware, and I've learned a lot. I have grown a lot, and I have experienced a varied set of kind of opportunities at VMware. So I'm a big VMware fan. I'm also an Agile Scrum evangelist. I strongly believe in iterative development, in iterative delivery of software. I kid you not when I say I apply Agile Scrum processes to my family, to how I get my kids to collaborate, to right from getting them to just talk about their day, what went well, what didn't go well, what could you have done differently, like how can parents help you. I know it seems a little bookish, so to speak, but it works out really efficiently. We get them to open up about things that they wouldn't normally consider sharing. So it's an opportunity for us to just set some structure around what we do as a family. What I do for my daytime job is I am a software engineer and an R&D manager for Cloud Director Service. I live in Austin, Texas, and we've been in the news recently for all undesirable reasons. But where I mostly am is on Slack and Zoom for most of the week, and that's kind of the situation for a good number of us, right? So that is a little bit about who I am and what I do. Now let's look at some of the technology buzzwords here. We've all seen a few of these appear either on, in tech talks, in white papers, technical blogs, release announcements, any other technology social media that you might be following. In pretty much every box or every hexagon out here is something that we apply, use for our project. CI/CD, continuous integration, continuous development, delivery, and deployment. Containers, we've heard about Docker and such, Kubernetes, which is again container orchestration. Cloud, which is what we do with VCD and CDS projects at VMware. Microservices, an architectural trend that is picking up. Agile Scrum, a software development methodology. A good number of us will be familiar with this. Virtualization, this is the bread and butter of what VMware does. SaaS, this applies specifically to Cloud Director Service or CDS, and we'll refer to our project as CDS going forward. Oh, I got cloud in there twice. I guess it's very important. Okay, and DevOps, which is pretty much how we run our service in production. Without DevOps, it would be heavy investment in manual intervention to deliver, maintain, monitor the service that we develop. So these are the topics I hope to cover. I intend to be kind of really high level on each of these topics and focus more towards presenting a picture of how these tie together. But if you want me to pause and clarify on something, please do let me know. Okay, so the what, how, and why. What we do on Cloud Director Service, we deliver a service. This is a managed service. It is a cloud delivery or cloud management solution, and we use SaaS as a delivery model for our service. Virtualization, which is kind of the underlying technology that we're productizing. Managed clouds, again, this ties into the SaaS concept. We'll go in detail about each of these. But managed clouds is where, as a cloud service provider like Rackspace or Oracle, we can go in and deploy an entire data center and a cloud delivery solution on top of that with the click of a few buttons. And the entire deployment, end-to-end, the infrastructure, the platform, the cloud solution will all be managed by VMware. And this wouldn't be any different from, say, how you consume Google Docs, where you don't have to own well, you have to technically own a computer. You don't have to own the server or the storage that your docs persist to. You don't have to buy the application. You don't have to deploy it. You don't have to upgrade it, maintain it, manage it. None of that. You log in to a specific endpoint on the internet and you're able to use your application. What we use to achieve this, we're talking about some of the technology, and we've listed a few here: Kubernetes, Docker, Git, Wavefront, Jira. This covers development, this covers integration, delivery, observation, monitoring, project management. For all of these are the set of tools that we use. This is not a finite list of what we use. We have a few more that I haven't listed here, but these are primarily the tools that we use. And how we do it. How do we develop our application for it to be a SaaS solution? How do we develop it for continuous monitoring, continuous improvement? We follow a certain set of practices, and some of those are microservices architecture, CI/CD approach, DevOps investment, and the Agile Scrum methodology. Okay, CDS and SaaS. Some of us might be familiar with what SaaS is. VMware has a varied set of products and services. There is infrastructure as a service, platform as a service, software as a service. Software as a service pretty much sits on the top tier. And I'm not going to dive into the details. I'll touch upon it a little bit in some of the upcoming slides, but I'm not going to dive deep just yet. If you're curious to understand in simplified terms what the difference is, I found some really useful material on the internet. If you Google for pizza as a service, that will give you an example of what the differentiation is between infrastructure as a service, platform as a service, and software as a service. It's amusing the way they've presented it, but it is on point. Okay, so let's talk about this list here for a second. With software as a service, we are able to enable subscription-based licensing, which means you do not have to pay for a license and manage your license. It is pay per use, just like we use Netflix. You pay for as long as you want to use it. Sometimes you have prepaid contracts for a certain amount of time, and when the contract expires or the subscription expires, you are not able to access the service anymore. It is highly agile because somebody else is developing it and managing it. So there is quite a bit of investment in delivering iteratively. There is continuous improvement happening, and it can be seamless to the user. The user does not notice any improvements or maintenance that is required. It is accessible from any location. It is accessible over the internet. You're free to use any client, most clients, because primarily services are accessible over HTTP. So you're free to use pretty much any client. Upgrades and updates are all done by the provider and the operators. In most cases, the users do not even notice it. For example, we don't notice what version of Gmail we're on, right? We only know that it keeps getting improved. If there are any issues, we raise tickets through a portal that is available. We report the issues to the provider and they fix it for us, right? Managed services is another aspect. For anybody consuming the service. For example, if we were to consume Google Docs, for example, and scale it out to enterprise customers, they don't need specialized personnel in order to manage the software. They don't need sysadmins. They don't have to hire them. They don't have to build data centers. They don't have to invest millions in brick and mortar data centers anymore. They don't need subject matter experts to develop custom clients. We can customize solutions very easily. You pay for a subscription, but there are no separate maintenance charges, so to speak, no licensing requirements, no piracy of software. So it's very easy on the customer. Also, there is a disaster recovery, site reliability. What happens when, for example, there is, knock on wood, an earthquake happening in one region? There is automatic failover and failback, and it's all managed and seamless. So there is uninterrupted service. And this is all transparent to the user. This is not something the user needs to be concerned about. Right? Now, how do you trust that somebody else is going to take care of your data? Keep it private, keep it secure. How do you trust that somebody else knows what they're doing? Right? That is why we have cloud compliance in place. There are so many different compliance audits that are required, and customers are free to verify these certificates and accreditations. Some of the examples are SOC or SOC 2, GDPR, ISO. There are quite a few. And these are all audits done by independent third-party assurers. So there is assurance that security availability is kind of ensured. Right? There is reduced business risk for customers consuming the service, and primarily there is pretty much uninterrupted operations that customers can rely on. Now, The next point is easy expansion to international markets. If it's on the internet, it's free for access for anybody. If it is free to access, not free to use, so you pay for subscription, but it's available for everybody, right? It's very easy to pick the solution up and deploy it in a different geography and have that be seamless to the user, and try and localize the solution for wherever the user is, right? And easy scalability. If you want additional storage space on your iCloud account, for example, what do? You go in and pay for a little extra and get a little more storage space. As an end user, I don't have to be concerned about how Apple does it for me, where they put it or how they do it. I go refer to their compliance certifications, and I'm sure that my privacy is ensured, and I'm automatically able to scale very quickly and with a click of a few buttons. So that was quite a bit, right? Are there any questions? All right.
I actually have a small question about how you manage like competing cloud compliance standards. So like presumably, like I think GDPR applies to specifically the EU, whereas they might have different standards in the United States versus elsewhere. Like how do companies keep up with that and ensure they're always compliant?
Right, that's a great question, Anuradha. So GDPR, like you mentioned, is local to EU. There are industry-specific compliance requirements as well. PCI is primarily for payment through credit cards. HIPAA, what some of us might have heard about, is for the health insurance and healthcare industry. So sometimes we might look at these as competing classes, but essentially they're not really competing. They're more like nested dolls, like subsets of compliance requirements. GDPR and ISO ensure the same parameters of security, privacy, identity management, change management. The controls for each of these compliance processes are the same. Just the fine print varies a little bit differently. GDPR, for example, requires your workload to stay within the EU, and pretty much any content that as a consumer you upload or workloads that you manage need to run within the geographical boundaries. So what we do for CDS is our application is actually deployed on top of AWS regions. So customers from the EU are rerouted to our application instance running in the EU. We have our service running globally. We have it in the US West 2 region. We have it running in Frankfurt. We have it running in Tokyo and Sydney. So customers from each geography are routed to their local AWS region for that purpose. And the service automatically does that by sensing localization settings on the incoming HTTP requests. So sorry, that was a little technical, but to answer your question, these compliance requirements are not necessarily in competition with each other, but in most cases they're complementary. So look, we can look at it as kind of a Venn diagram where there's a little bit of that union section where they all have a certain set of controls in common, but each has their own specific controls that don't necessarily contradict each other. Okay. All right, now the exciting stuff. Agile, Scrum, CI/CD, DevOps. We could use one independent of the other. We could use them all in a complex manner. But on CDS, this is the cycle that we put to use, and they are not independent of each other, but kind of a complex integration of all of these different topics, right? Let's touch upon Agile Scrum quickly. Agile Scrum is nothing but an iterative approach to delivering software. I build something today, I improve on that tomorrow, and then I keep going forward. I make sure that everything I do, everything I develop gets built properly, it gets tested adequately, it gets released in a specific environment control process, it gets deployed, wherever it needs to be deployed. And then again, keeping SaaS in mind, we operate the service, manage it, maintain it, upgrade it. We monitor it because we own the service. The customer will be using it, but we pretty much run it. So we monitor it. Based on observations there, we feed back into the planning cycle, which will lead to improvements in code. So this is kind of the infinity loop that we follow pretty much. And this entire loop forms the DevOps cycle. Now, the first bit of planning, coding, delivering, testing, releasing, and then repeating. That blue circle that you see within the, the green oval is the agile development process. We keep repeating it, and hence we iterate on our solutions, right? For CDS, there is a reason why we need this model. In SaaS, typically the expectations for delivery are pretty high. Something's broken, I need it fixed today. We've all been consumers of online services. When Gmail is down, we are. It's a major blocker for us, right? It's not desirable even as a service provider to not iterate upon solutions, to not quickly deliver solutions. So the feedback cycle needs to be quick. When it needs to be quick, you can't deliver large amounts of changes in one go. It needs to be in smaller iterations. However, because you need the response to be quick, human intervention is not convenient. It is possible, but it is not the best return on investment. We will be throwing a lot of bodies at operating and monitoring the service versus focusing primarily on improving and evolving the service. So DevOps becomes a primary requirement. And in order to achieve DevOps, CI/CD, continuous integration of changes that go in, and the ability to continuously deliver to the SaaS project, that becomes necessary as well. So Agile Scrum, CI/CD, DevOps, these go together hand in hand for us. So on CDS, we have it's a combination of practices and tools that we use to release at a very high velocity. We are capable of making multiple releases a day to production. However, the planned release cadence is once every 2 weeks, and we align that with our agile scrum methodology with our sprints, which again run for 2 weeks. We however, with customer incidents being reported, we're able to respond much more quickly. The tools that we use for the three major keywords here are we use Git for development and continuous, we use Spring Boot and IntelliJ for development, and Git for continuous integration, Jenkins for continuous delivery. We can break that into two pieces. For operations and the ability to monitor, we use a whole bunch of tools. We use uptime.com, which has probe servers going and checking endpoints to establish liveness and readiness of the service. We have Wavefront, which plugs into the Docker containers, the Kubernetes clusters, in order to monitor the health and be able to predict any for example, memory consumption or CPU consumption patterns. So it's pretty much used for observability. We use PagerDuty. We're all on PagerDuty. We get alerts when something's wrong. And for collaboration, again, we use Slack. And what has become the superstar of the pandemic, we use Zoom for a lot of our communications. So we have automated tests. That is kind of part of the continuous integration development cycle. We have automation tests because we do not have the time to serialize development and quality assurance. We need it to be done as we develop and integrate software. So there is a lot of investment going into automated testing. There is continuous automated monitoring to stay on track for service outages and degradation. We have some opportunities to provide automated remediation. If, say, there is an outage, could we quickly restart a pod, could we quickly refresh a particular probe. So those are automated resolutions that we have in place. There is some manual intervention for immediate remediation of problems. If something is out, what do we do? How do we bring it back up as quickly as possible? And then there are longer term improvements. Customer notices that sorting on a page is not proper. Customer notices that when they've requested for a whole list of endpoints, for example, they only get a subset of it. So these are bugs that are reported that will take slightly longer. And when I say longer, again, it's we're trying to achieve the 2-week response time in terms of bug fixes with longer term resolutions. However, we have very high standards when it comes to making the service be available. So these are industry-wide cloud compliance SLAs, or service level agreements, where we say, as a SaaS, a subscription-based SaaS project, we make a commitment to have the service be available. And again, the service level agreements are from month to month. So we have a commitment to have the service be available pretty much 99.9% of the time. That gives us a downtime allowance of 43 minutes per month. That includes maintenance, updates, upgrades, any outages that might happen. Those are industry standards. At CDS, we are actually beating that a little bit. We've cut that outage in half, and we're at 99.95% now, which means we have had about 21 minutes of outages over the past few months. But our goal is to go to 99.99, which is less than 4.3 minutes of outage per minute. And this includes every entity across every geographic region that we support. All right, any questions here? Anything I can answer? Moving on to the next slide. The way we do this, the way we iterate, is to build a minimum viable product. We have to continuously improve on what we're delivering, but we need to make sure that what we're delivering is actually what the customer requires, and that this is improvement in the right direction. And I found this image which pretty much, got it on point, right? The first option, which is typically the waterfall model, where we build bits and pieces and then we put the whole picture together. That is not how we can build a minimum viable product in a SaaS environment following the agile methodology. The second option is closer, but it is a very expensive way to build something, because typically a customer doesn't necessarily want a bicycle and eventually have us deliver a car. They're asking for a car. It's okay if it doesn't have all of the bells and whistles, it doesn't have all of the fancy lights. However, what they asked for is a car. And the best investment is in building a car versus building a scooter and then changing that to a bike and then modifying that to be a motorcycle and then to a car. That is a relatively low return on investment. So the best way to build a minimum viable product is to scale down, but to build the right product. So if we look to the right, some of the key concepts here are: build the right product, build the product right, which means set very high benchmarks for quality, iterate on development, like keep continuously improving, iterate on delivery, make sure it is continuous. The keyword here is viable, viable meaning usable. And this is exactly meeting customer needs, maybe at a scaled down level, but it meets customer needs. And it should be based on real feedback from the customer. And the way to go about it is build a proof of concept, improve that to be a prototype, and then have that meet the minimum viable product standards. And then rinse and repeat. Go through an MVP for pretty much every iteration. every time software gets delivered, however quickly, however rapid the release velocity might be, make sure that this is the minimum viable product that the customer can use. It's not something that we would like to see there. It's something that the customer actually needs and wants. All right, next one is, okay, this is a nuanced conversation that you might have noticed on many forums. Agile development doesn't mean we are being agile. Sometimes we end up doing agile and not necessarily being agile. And this slide is slightly off topic, but just to give the whole picture of why being agile is much more of a requirement when it comes to continuous delivery to a SaaS service, right? Doing agile, which is following agile processes, means there is a plan and we go by it. But being agile means the change drives the work. We focus on what the customer wants and what changes they're asking for and have that delivered. The agile process is focused on, it's problem focused and process focused, whereas being agile means it's solution focused. Whatever I'm building, the approach is, am I solving this problem? That is not the approach. The approach is this solution going to benefit the customer? Right? Continuous delivery is the agile development process, but being an agile service means there is continuous learning, there is continuous feedback, there is improvement in quality in doing the agile process, and being agile, there is improvement in innovation. Iterating on solutions is the way you do agile, but collaborative solutions, including continuous feedback from a customer, having collaboration within a team, having self-managed teams, for teams to be put at a point where they're exposed to customer feedback. That is how we differentiate doing agile versus being agile. Directive leadership, in which product management, for example, dictates what work needs to be done, or planning work based on resource management. That is how we do agile. But being agile means collaborative leadership. Engineers have a say in building a more equitable product. There is a bottom-up feedback loop into how things are being built. I'm not saying one can exist without the other. It needs to be a collaboration of both. And these are actually two different things. And they need to come together to a happy merger to make sure that we succeed in delivering a SaaS service. Okay. Microservices. There is plenty of material available on the internet about microservices, what they mean, how different is it from older methodologies and things like that. But we do use microservices, and I wanted to touch upon it really quickly to show you how that falls into our DevOps kind of picture. Right? Microservices evolved from service-oriented architecture. Previously, we had monolithic applications where you would have the database on a server, then you would have the business logic sit on top of it, then you would have the UI sit on top of it. It's kind of a single-tiered model, single stack, and you use maybe one or two servers to kind of host the entire thing, and that's how it goes. It's primarily reliant on MVC approaches. We've seen a lot of that in the past. Microservices, whereas, are very loosely coupled services that are tied together by APIs. Each service has a specific responsibility and ownership, and it does exactly that, and it does it well. It's very efficient in doing that. It is able to effectively communicate with pretty much any other service from which it requires input, and it's able to do the relevant work in a very efficient manner. In most microservice architectures, there is a heterogeneous environment where every microservice may be talking to a separate database instance. It could use different technology. There could be a C++ application, Java application, like each as a separate microservice. So that is possible. With CI/CD investments made, CI/CD, or continuous integration testing development, becomes easier with microservices. There is initial upfront investment in buying the tools needed for it and having people try and build the framework. But once that is done, It is very easy to add services and to expand the complexity, right? Each service can be really lightweight, which means each service doesn't have to sit on a server. You don't have to spend, say, $6,000 on a rack server just to run one application. Every microservice could run in a container. A container is simply a granular slice and dice of compute storage resources for networking resources for an application. So imagine 10 different microservices, each being relatively lightweight and running within containers, right? So there is that added advantage. There can be some disadvantages. We could go overboard with microservices, have way too many microservices developed. And then there is the encumbrance of maintaining everything, and there is a cost impact that comes with it. So I would say microservice architecture is done well if um, the design is intent driven. We do not have the architecture dictate an organic growth, but to have it be intent driven. And that would be kind of a good happy medium between the slippery slope of microservices versus the advantages. Any questions?
Yeah, I have a few questions. So I know that you just talked about how microservices are best done when they're intentionally thought through. Could you expand on that a little bit more? So like examples of when I guess what you're trying to say is microservices for the sake of microservices will create lots of unnecessary costs. But if you could elaborate on what doing it well might look like, I think that would be really helpful.
Right. Okay. So I could give you an example. Let's say there is a legacy application that has been built. Legacy meaning it's just been in existence for quite a while, and it's gotten to be a thick application. There is way too much business logic going on. Then intent-based architecture with microservices means identifying the purpose of each part of business logic and separating it into a separate service. However, if, for example, user data and infra data. So we have newer concepts again, like infrastructure as code, Terraform, Helm, things like that. I haven't covered that in my slides. That's something we use, but again, it's kind of a technical deep dive. But there could be infrastructure data that needs to be stored as well as user data. And if we have a microservice that exists to retrieve user data, then there is no reason why that microservice cannot be put to use to retrieve infrastructure data as well. There is no need for two separate services to do that job, because at that point, the intent must be to build a microservice that fetches data from a database and does that efficiently. The intent could be misplaced where we say, well, I want a microservice that focuses on user data. That may be a reason, a good enough reason for heavy investment into another microservice. If, for example, there is a lot of traffic with respect to user data compared to infra data. If that is not the case, then it makes sense to reduce the footprint and build a single service that acts as a data access service versus a user data access service, right? So you have to analyze the intent behind building a service and the purpose for it. And that has to be very conscious thought. We might have all of the infrastructure in place to continuously develop and spin off microservices, and it might be easy to begin with for day zero operations to say, hey, I've spun up a new service, it'll do something new and cool. But what to keep in mind is, how are we going to maintain this for the next 2 to 3 years? If there is increase in data, will it scale? So there are so many other things to keep in mind while architecting this kind of solution.
That makes a lot of sense. I think that kind of answered my question, because I think the example about how if there's a lot more traffic with like specifically fetching user data, then you want something lightweight, whereas otherwise you might want something reusable. That really helped clarify it for me.
Okay, awesome. Any other questions? Okay. Now, this is kind of what I do, Cloud Director Service, and I'm really excited. To be honest, this is by far the most exciting project that I have been on in my career, because we get to work with really cool tools. We get to experiment with really cool processes. And now, after about, I would say, less than 18 months since inception, we are at a happy state where we know what we're doing is right and that we're doing it right, and that this can scale. This is a growth opportunity for VMware. Cloud Director Service is a high visibility project, and I get to work with a bunch of really cool, sharp-minded engineers, and that's really exciting. And again, this is a growth market for VMware. So again, that's generating a lot of interest within the company, right? What is Cloud Director Service? There are a few slides that I have coming later, which will talk about what the cloud delivery solution at VMware is, which is VCD. Some of you are working on it. Some of you might be familiar with it. Cloud Director Service is taking that product that, for example, like MS Word, you used to have to buy on a CD or download, and then use a license key to install, and then you had to pretty much like make sure it functioned well, and you're upgrading it once in a while, and you're kind of backing it up with storage and things like that, right? It's like taking that and putting it in a service that VMware completely manages. We say, you want to set up business as a cloud provider. You want to set up shop to say, anybody, any enterprise like Coke or Pepsi or anybody who needs compute and storage and networking capacity in cloud, you need that. Well, I don't have a data center in your area, but that's fine. I go to CDS, click a few buttons, and I have the infrastructure and the services required to operate as a cloud provider with a click of a few buttons, and that's it. Like, of course, pay with your credit card, but it's there for you. Few minutes, right? You don't have to go through the investment of building out data centers, having people on the ground, brick and mortar buildings, buying up servers, hiring system admins and cloud solution engineers, putting everything together. Like, you have 2,000 servers. How do you collect the resources across those servers? How do you put them together? And then again, how do you slice and dice it up and again resell to other people, right? That is not a concern anymore. CDS will do that for you, and everything can be done through the internet. And that is the SaaS-based cloud delivery solution. I spoke a little bit about the asset light model, where companies with not a lot of revenue, smaller sized service providers, for example, in smaller countries, like let's take Madagascar, for example. The state of, or the country of Madagascar would like to run their own cloud deployment for their state operations, but they don't have the money to invest in building an entire data center, or they choose not to put their money there. Then all that they need to do is, again, go to the internet and buy up through CDS. No assets that need to be maintained, no security guards, nothing of that sort, right? Global expansion. So I think we touched upon it a little before. We're primarily relying on AWS regions for infrastructure availability. So if, for example, we need to roll out to a new geographic region, it would take us less than 2 weeks as kind of operators of the service to expand to a new region. We, again, don't have to go through the same encumbrance of like setting up a data center in a different country. In fact, we're working on rolling out to Sydney, Australia, and we have Dublin and London coming up on our roadmap. And the investment in that is one person working on it for maybe a week, and then we're done. We have a data center set up. Managed services, VMware does the management. You have any issues, you report them to us. We go in and alleviate it for you. If you were running a data center, then you have to have system admins go in and manage your infrastructure, manage placement, swap things out, simple basic operations, and then much more complex operations built on top of it, upgrading, maintenance. None of that is a customer's concern anymore. VMware will do it for them. And VMware will do it transparently. Provider customization. So for example, if a service provider comes to us and buys up CDS, they are going to provide cloud solutions to many other tenants. Rackspace might come to CDS and say, hey, I want to accommodate Coke and Pepsi in Denmark. Like, what can we do? They can procure the resources and they can customize it. So Coke and Pepsi don't see that they're going to VMware. We can customize both branding, with customized domain names. So Coke and Pepsi, in all respects, think they're going to Rackspace's own domain and Rackspace's own solution. So we customize it for the cloud service providers. What if a provider has a data center already, and now they're buying up some resources on CDS, and they don't want different management planes? We do that too. We put the resources together. We give them a bird's eye view of all of the resources that they manage in a one-stop solution. They just need to go to one service and they're able to manage everything. Multi-cloud. So I mentioned that we abstract our service on top of AWS. We're going to do that for AVS as well. And then we have Google Cloud coming up. We have Dell Dimension coming up. This sets up a multi-cloud format where customers might want one particular underlying cloud infrastructure, and they want a VMware solution on top of it. They don't want to go to AWS, they want to go to Azure. And AVS is the solution. So we're able to do that for them. And we can tell them it's all in AVS, but they don't have to be encumbered by the nitty-gritty of running a service on Azure or AVS. The last one, again, is operator-owned upgrades and maintenance. VMware does all of that for you, and it's transparent to the user, right? That is pretty much what we do as a team, day in and day out. Okay. Now, this is a little complex. This is what vCloud Director is, the on-prem version of the SaaS project that we do is, right? Assuming this is what you see around here in the green box is the data center. This is a physical building where we have a whole bunch of rack servers. They talk to each other, they network with each other. Each has storage capacity. There might be network-based storage. It's all in individual rack servers. There is a layer that goes on top of it for the aggregation of these services. If I want to run a data center, I don't want 10,000 separate servers or 1,000 separate servers. What I would like to see is a large resource pool with a large amount of compute capacity and storage capacity. The capacity of every server needs to be aggregated and presented to me as one large pool. So I can take it again and splice and dice it and say, hey, tenant A takes this, tenant B takes this, and you don't know that you're all on the same configuration, right? So the aggregation layer is a different VMware product called vSphere, and that does the software-defined data center, so the software that manages the entire data center. On top of it sits vCloud Director. vCloud Director is the tenancy solution. That is the piece that says, fine, the data center is now presenting me with an aggregated resource pool, but I take care of maintaining multiple tenants and each being by themselves, each having the computational boundaries that they're asking for to maintain privacy and security of their data, right? And on top of it, there is asset management. We don't want to direct one tenant to one underlying server all the way down the stack. We need to be able to optimize to say, well, there are certain servers with a lot of spare capacity and there are certain others that are overloaded. So let me distribute the load. So all of that is managed through placement logic within VMware Cloud Director. That is the product that we put in containers and we manage and maintain. So the customers don't have to build this entire green box all on their own. All of this disappears to them. And all that they get is an endpoint on the internet that they can log into and do the exact same things that they would do if they were to build an entire data center and deploy the entire stack of cloud management solutions. Right? Now moving on, this is kind of a tricky slide. The only difference between this one and the next one, which is CDS, is what we have lying underneath. Again, the whole point is we don't expect providers to manage their own load, which means they don't want to build their own data centers. So we do not base it on physical data centers at all. It's completely based on AWS currently. And like I mentioned, we're focusing on putting the workload on ADS as well. So no brick and mortar data centers, no actual bare metal servers, nothing of that sort. All of the infrastructure is on AWS. How AWS does it is their problem. They guarantee availability to us. We guarantee availability to our customers. There is kind of a chain of responsibility there. The way we do it, right? How do we take this entire virtualization infrastructure and make sure that we have it as a highly available and highly reliable service? That is where this comes in. There is the data center, which can be accessed on the cloud. On top of it, we build VCDs. We put them in Kubernetes pods, and Kubernetes is kind of a container orchestration tool. Every container is Docker based. So there is an application of VCD running within each container. That container has replica sets. So when one goes down, the other is maintained online, things like that. So there is high availability. And there is redundancy, there is transparent failover, rolling upgrades. So while we're upgrading one pod, the other is still able to service customer requests, and then we switch over and then upgrade the next one. All of this is done through Kubernetes. And again, that all sits on top of AWS. So to a customer, again, through the internet, they could just log in and work on the data center, operate the data center without having any concerns of upgrades or maintenance or deployment. Okay, what this gives us is unified cloud management. This could be, I think there was a little bit of animation too, sorry. We could keep expanding CDS coverage across the world to multiple underlying data centers. We could build an exclusive data center. It could be a VMware data center, for all we know. It could be on AWS. It could be on other clouds. It could be on VMware Cloud. It could be on Google Cloud, on Azure, on Oracle. It will be a VMware solution on top of all of that. The benefit is we have a good number of customers on VMware solutions already. Virtualization is was kind of primarily introduced by VMware, right? They were the pioneers with virtualization. Now, the whole shift into a SaaS-based, subscription model-based solution is kind of the next steps of where VMware would like to go. And when we do that, we want to take our customers with us. We want to provide the benefits of an asset light. When I say asset light, it means not owning any infrastructure. So an asset light environment or a hybrid environment, whatever the customers desire, with very minimum upfront investment. That is what we would like to achieve. And Cloud Director Service, through its SaaS operations, through the user interface, is best suited to satisfy those needs of our customers. Any questions here? Okay. All right, so that is pretty much the end of it. If you have any questions overall, I'm glad to answer them. Okay. I wanted to introduce you all to a few good reads that I have on my reading list. I'm actively reading the Accelerate book, and in case the pandemic kind of leaves you with a lot of spare time and you want something to kind of occupy yourselves, then these are good reads. These are all relevant to the presentation that I just gave you. It is very relevant to what we're doing, and I go through these books. I'm actively reading Accelerate. I started on Subscribed and then put a hold on it, but I would want to continue that and then go back to Leaders Eat Last. These are 3 books that were recommended to me by different people. Accelerate was recommended by my VP, who has a lot of experience running SaaS operations and cloud solutions at Oracle, and is now doing the same at VMware. Leaders Eat Last was recommended by my husband when I switched from an individual contributor to being a manager. And Subscribed was recommended to me by my mentor at VMware, Harold. So these are all good reads, and if you have any time and would like to kind of catch up on some of the topics, then I think they're good reads for you. I have some credits here for some of the images. And finally, I wanted to thank Anuradha Lal. Thank you so much for kind of staying in touch with me through the process and kind of facilitating this. This has been a really exciting opportunity for me. I hope we meet again. I intend to kind of keep in touch and follow up on VMware engagement with Northeastern. So I'll work with Joel on that. I wanted to thank Joel because he asked me to do this, and it's been a lot of fun, I should say. It's a break from what I do day in and day out, and it's really exciting to be talking to you. And I wanted to thank Emma. We hashed out a few ideas. You were able to make time for me, so thank you so much. Some of you might know she's a co-op with one of our VCB teams in Boston. And I also wanted to thank my team. I have an amazing team, a great set of driven engineers. And if any of you would like to consider VMware for your internship co-op opportunities, please reach out to us, Joel and myself. I'm Shivi at VMware.com. That's it, first name, Shivi. And I wanted to let you know that on my team specifically, we have a couple of team members, experienced team members from Northeastern. So I enjoy working with them, and I know there is so much that the university is offering to you guys. I hope that you're able to derive maximum benefit out of the crazy situation we've all been forced into. And I hope you have a really good evening. Thank you so much for entertaining me here.
Thank you so much for coming, Shivi. That was extremely thorough, and I learned a lot of information, and I'm very excited to check out those books you recommended. For those of you who came to this meeting, thank you so much for coming. I hope you learned something valuable, even if you're first year and this was all like, whoa, tech. Well, tech is a crazy world and there's a lot to learn, and hopefully that should inspire you to continue learning about this as you go on through the next 4 years. And if you've been on a few co-ops, you know a little bit about cloud technology, hopefully this has expanded your knowledge. So feel free to do what you like with the rest of your evening, and I'll see you guys next Tuesday.
Anuradha, sorry, if I may say something really quickly. You mentioned something very interesting, and I thought I wanted to double click on that. Right? We, as a team delivering all of the stuff that I talked about, all of the mumbo jumbo of cloud computing, right? We struggle day in and day out with newer emerging technologies. We are uncomfortable. We are inconvenienced. We go through imposter syndrome time in and time out. Right? We struggle with the same set of challenges that you possibly, maybe at a different level, but still the same nature of challenges that you might be looking at as freshmen or sophomore students at an engineering program. But the one recommendation that I have is keep going. There isn't another option to learn. You just got to keep going. Don't let any of this stop you or discourage you. If you have questions, as simple or silly as they might sound, ask them. And disregard any commentary around any of your questions. Right? Just go ahead, forge a path for yourself, and keep trying. Don't stop. That would be my recommendation.
I have far less experience, but I 100% agree. That's never failed me yet. And with that, I'll give you guys the rest of your evening back to you.